Okay, example 4 from this lesson is something that you've seen last year, except now that it's going to be in a Radian question instead of a degree question. And this makes it quite a bit more difficult because in our heads we have a tougher time understanding how big a radian is. In fact, what does this even mean? Alright, well it means that theta, the measure of the angle, is somewhere between 2 pi, so this would be 2 pi, and negative 2 pi. So thinking about that in terms of degrees, that means it's somewhere between negative 360 and positive 360. Okay, so what is that asking for? It says there's a point negative 4, 3, so let's draw that. Here is negative 4, and this is 3. In fact, let's turn it into a triangle. Okay, and it says that's the terminal point. What is the measure of the angle in standard position? Okay, now we got to be a little bit careful here. We're looking for actually two angles. We're looking for this angle, that's standard position, right? It starts at the initial x-axis. We're looking for that angle, but we're also looking for this negative angle. Okay, so how do we do that? Well, whenever you're finding an angle in standard position, always find the reference angle first. Here is the reference angle, and this is the one that we can find because of the information we're given. Okay, so how do we figure that angle out? Well, we need a trig ratio. We need either sine, cos, or tan. Well, if you use Pythagoras, you'll figure out that this is 5, but you really don't need that in this case. We can figure it out using tan. I know that tan of theta is 3 over negative 4. Now, bad news. I'm not going to do that. Why not? Well, first of all, this is not really theta. This is my reference angle. So I want to find the reference angle first. So I can do tan of the reference angle over 3. Is equal to 3 over negative 4. But remember I told you that we never use a negative angle for the reference angle. So I'm going to go positive 3 over 4. If you want, make a little note right there. Okay? This should always be positive. Whenever you're finding a reference angle, it's always going to be positive because a reference angle is always between 0 and 90 degrees, or 0 and pi over 2. Okay? So, you're going to go theta r, and then we're going to go inverse tan of 3/4. Now, before you grab your calculators, there's something else different here. We're finding this in radians. So you need to change your calculator into radians. Okay? How do you know if it's in radians? Well, on the screen of your calculator, it's either going to say rad, or maybe it'll just say R. Okay, it's got to have one of those things on the display. Okay, and you're going to have to figure out where that is in your calculator. Every calculator is different. If you can't find it, you got a couple options. You can go and just Google search it. Google search your particular calculator and say, how do I change to radians? Or you can bring it into class whenever we have class, and I'll help you with that. Okay, so the reference angle, I think in this case, and we're always going to 3 decimals, is 0.644. Now be careful. Don't use this value. This is the rounded off value, right? It's actually much longer than that. Use whatever is ever on your display here. Okay? Keep your display, because now we're going to figure out the angle. So what is the angle in standard position? Well, the first one is going to be pi take away theta r. So you're going to go pi take away whatever's on your display here, and I think you get 2.498. Okay, and the other angle is going to be from here to there. This is going to be negative pi, because now you're going clockwise. Negative pi take away theta r. And this is going to give you negative 3.785. Okay, those are the two angles go to that terminal point. All right, we'll try another one. This one's very much like that. It says given cotan is -2. Now, if you are given cotan theta is -2, this means tan is -1/2. Let's use this because that's a button on the calculator. Now it says tan is negative. Where is tan negative? Could be here, could be here. Okay, so let's turn those into triangles with a reference angle. Notice your reference angle is always to the closest x-axis. Okay, it would never be here. All right, and it says -1/2, that's opposite over adjacent, so 1/2, the negative should be here. And then over here, you've got -1/2. Okay, finishing these triangles off, if we use Pythagoras, I believe this is going to be √5. And the hypotenuse is always positive. Okay, so now we've got our triangles. Now we're supposed to figure out what is the measure of the angle. The angle is always the one in standard position. So we're going to figure out this angle, and we're going to figure out this angle. All right, so let's write theta down here. You're going to have, that first angle is going to be pi, take away my reference angle, and the next one is going to be, how do you get that one? Should we go to pi and add a reference angle? No, we should go to 2 pi and take away a reference angle. Okay, so those are the 2 positive angles. Now you're also going to have 2 negative angles. You're going to have this one, and you're going to have this one. Okay, so what are those? They're negative. It's just going to be the reference angle, but negative. And then it's going to be negative pi take away the reference angle. Those are going to be my 3 angles. All I need to do is figure out what is the reference angle. So to figure out the reference angle, I'm going to go inverse tan of a half. This is going to be my reference angle. And so the reference angle is 0.464. Okay, now putting that in for each of these questions, I'm going to get 2.678. I'm going to get 5.820. I'm going to get -3.605 and -0.46. Oops, I got those backwards, I think. Yeah, this one's -4.464, and this one's -3.685. Oh, 05.